Hi, this is Anthony Garland at Garland Industries LLC, and today I'll be showing you Graderworks and how it works. So first we're going to start out on the Garland Industries website. So this is the main page. And to look at the software Graderworks, I'm just going to click onto software, and it's right here. To download it, just click download, and then you can get the 30-day trial. And there's some more information on the website. So I've already downloaded and installed it on my computer, and let's go ahead and look at it. So I open Graderworks on my laptop. Um, this is what it looks like. So there's a few things. If I go to File, I can change the root directory. I can also configure it. A bunch of different settings. Start the analysis, stop the analysis, and some help options. So I'm going to show a demonstration of Graderworks analyzing files, and the files that I've chosen I got off GrabCAD. So I went to GrabCAD and I just searched for caster, and I changed the software type to SolidWorks. And then I downloaded about 40 different caster wheel designs off GrabCAD, and I put them into a folder. And these are zip folders that have been downloaded. So if we go to this folder here, caster wheel example, here are all the files that I downloaded. I also renamed each one to have a prefix of student and then a number. And this would represent the student's username for this particular file. So again, these aren't actual student files, but it's just an example. The underscore represents the end of the username, which is similar to what happens if you download files off a course management system like Blackboard, and it will rename the files automatically with some type of convention that you can use to analyze or to extract the username. So if I go to Graderworks now, what I'm going to do is first I'm going to tell it that this is the directory where I have the files. So I'm just going to copy this path and paste it as the root directory. Next I'm going to click on configure. Graderworks can analyze a bunch of different, has a lot of different settings, can do a lot of different types of analysis. The first thing I'm going to do is tell it how to identify the username. So here for the start identifier, there's no start identifier because it's just the beginning of the file name up until the underscore. So the end identifier is the underscore. Next, there's lots of different types of ways that the student's files might be downloaded. So I can do just SOLIDWORKS files in a folder, or folders containing SOLIDWORKS files, or in this case, we have zipped folders that contain SOLIDWORKS files, or I can just specify like individual files that aren't necessarily all in the same folder. For the type of SOLIDWORKS file to analyze, I can do parts, drawings, or assemblies. Now let's look at some of the other tabs on this configuration. So if I go to advanced, I can see that I can save each part as an STL file or save an isometric screenshot of the SOLIDWORKS file. Also, I can like analyze and export the feature data if I wanted to. If I wanted to analyze specific files that were not all in the same folder, I would specify them here. And finally, we can also do a comparison to a reference or like a correct answer type file. That's what we're going to do in this case, in this demonstration as well. So I've unzipped one of these files that I downloaded, and I put it into this folder called ref, standing for reference. Then I'm going to sort by type. I'm going to take these three SOLIDWORKS part files right here. I select all three. Then in Windows 10, I'm just going to click copy path. And then over in this box, I'm going to paste this into my into this box. So these will be the three files that's going to analyze all the other files with respect to. Also, I'll need to check this box. Okay, so now it's all configured. And then we can start the analysis. So I'm going to click on Start. And what it's going to do, it's going to run SOLIDWORKS in the background. Sometimes it will bring SOLIDWORKS to the foreground if there's a unique issue. Like I've noticed that sometimes if the files were submitted from a previous version of SolidWorks. Sometimes it'll bring it to the foreground, like right now. So you can see it's going through and opening all the parts. And what it's going to do is it's going to extract the mass properties of every part. And it's going to also extract metadata, such as the last saved by username, the last saved date, and the creation date of all the files. In addition, it's going to do that comparison to those three parts. So if we look here in this window, you can see it's pre-analyzing the fork, SolidWorks part, the stem, and the wheel. So that's getting the file comparison ready. And now it's going to analyze all of these parts that it's opening with respect to these three SolidWorks files. So it's pretty interesting looking at how other people have modeled the caster wheel. There are some people that used a single part with multiple bodies, and there's other people that used assemblies with multiple parts. It probably would be better to do a assembly with multiple parts, but it's just interesting looking at like what other people have done. If we look over here at the Graderworks window, we see and here at the bottom that it's giving me an estimated time till finish. So it says about 4 minutes left with an end time at 2:31. And that can be really helpful information. So if you're analyzing like hundreds of students' files, this information can be really helpful because it can kind of tell you how long, how much longer you have until you can use SolidWorks again for something else. Because while it's running, you won't really be able to use SolidWorks because SolidWorks is running already. So when it finishes, it's gonna output two files to the root directory. You can already actually see the first one. So the first one is going to be output.csv, and that's going to contain information about like the mass properties and the metadata. Also, it's going to add output at analysis.csv, and that's the one that will indicate files that need to be examined more closely for potential cheating, or it looks like a student may have gotten a part or a file from an unauthorized source. So for those analysis.csv files and the files listed in there, you need, just depending on the type of assignment that you have given, you'll need to like intelligently think about what constitutes cheating and what isn't okay. So for example, if you like give the students a part file, obviously that it's going to be flagged saying that, oh, everyone has submitted the same thing, but it's actually okay. Okay, so now it's finished. If we look at the window here, it says job finish. So if we go to the root folder, caster wheel example, we see that everything's been unzipped. If we look at a student's file folder, then it has the unzipped files in it. You also notice that the name of the unzipped folder is the student's username, which can be really helpful. And then we have these two CSV files. So let's go ahead and take a look at the first one, output.csv. So this is the output.csv file. Let's take a look at the heading. So first we have the username. This is the extracted username. Then we have the file path. So that's the complete absolute path. Then we have the file name, which is just the last part of the path. The type of document. So we can have SolidWorks parts. We can also have assemblies and drawings. Mass. Obviously the like drawings don't have mass. So just the parts and assemblies. We have volume, density, surface area, center of mass in the X, Y, and Z. We have the SolidWorks saved by information, so who last saved it. We have the SolidWorks creation date. We also have the last save date. Finally, on these last three columns, we have the comparison score with respect to the fork, and then the stem, and then the wheel. Okay, so Um, Based on this information, then we could grade the files with respect to the mass. So here's the mass. I could write like an Excel formula that would check to see if this is within an acceptable bound. Also, we're interested in seeing how similar these are with respect to like a correct answer file. So this is pretty interesting. We have this fork. It says it's pretty similar, 52% similar to this caster. So if I go to SolidWorks and actually open these two files, so let's go ahead and do that. Let's make a new window, open this one. So it said this caster. Sometimes if SolidWorks is still running in the background, then when you the menu shortcut that the Windows clicking right here won't work. You just need to open SolidWorks manually. So this is the caster, and then if we compare it to our reference part, we said that this was the fork, not SolidWorks part. So let's open fork. And if I take a look at both of these, this does look pretty similar to this. And here they drew everything all as one part file. So like obviously the wheel and this top plate are not similar, but this middle fork area is similar. So you could say it's about 50% similar. It sounds reasonable. And this in the output was able to identify that. Also, you can see this thing. It's kind of similar to the stem. Also the wheel, which makes sense because it has a stem and wheel in it as well. So as we go through here, if we look at, for example, this student 14, if this were actually a student, I would be interested in finding out more information as to why two different usernames saved the files that he turned in. Like that's not normal for a student that's working on his own computer to suddenly have a different username as his last saved by. Also, if there are files that were created excessively long ago, the Graderworks program will flag them in the analysis.csv file because maybe they got it from the internet, maybe they got it from GrabCAD. It's hard to say. So let's see if there's any other similar files throughout here. So these, like they're relatively similar. This part right here, part 2. Let's try opening that one, see how similar it looks. Just gonna close this, close that. And the name of this was part 2. So we're comparing this file with respect to the stem in our reference. So let's open the stem. You see they look kind of similar. It's not quite as clear, but it's basically like a flat object that's probably similar in size, which is why it got a relatively high similarity score. Let's check out this one. So we have an 81% similarity. It's quite similar. And again, in this case, it's kind of random. It's not necessarily expected they'd be similar because they weren't trying to alter all the same thing. But normally in a classroom example, students are all trying to draw the same like part, and then you can use the similarity score for grading. So let's look at this. And I said we were looking at part number 2. So this looks very similar to that stem, or to the fork part that we looked at just a minute ago. Except for this fork has that bolt going through it, whereas this one does not. Besides that, also I guess there's a small difference here, but basically they're very similar to each other. And that's why I got that high similarity score. So we're able to use this information then for grading. And you can just, again, write Excel formulas that will use this information to output like a final grade, just depending on how you assign your homeworks and like what information you're actually after. Now let's take a look at the other output file. So this is the analysis.csv file. And we have the same types of headings. So we have the extracted username, file path, file name, type, mass, volume, and so on. And then it's going to find files that we should take a closer look at. So this first one says there's an inconsistent save by name for student 11. So we see that this guy, he has two different save by names, which is might be okay, but oftentimes that means that this other file is from another source, not made by the actual student. Here we have a duplicate save by name. So if two students like share a file, then it's quite possible that their save by name will be the same. So student 13, 18, and 5, they all use the same username as administrator, which can be fine. It is something we might want to look into. Duplicate saved by name H. Dearder. So student 23 and 24 and 25. So this is interesting because apparently this same guy made all these parts on GrabCAD. So I guess he made a lot of caster wheels. Again, duplicate saved by name for two different students, student 29 and student 36. So this guy, he made both of these parts, the rigid.solidworks file. And this is where it gets the most helpful, actually, the duplicate creation made for different users. This is the most common, the easiest way to find people who have shared files. So these guys, student 2, they all got these parts, which are they might be from like the toolbox or something. So it looks like they're primarily bolts and screws and stuff like that. But they were all made in 2015 at exactly the same time and second, which is unique. So that might be something that we might want to look into. This part right here, this rigid part. So this is interesting because it's student 29 and student 36. So two different files are downloaded off GrabCAD, but they must use exactly the same part because they were created at exactly the same time. You can see that their last saved by name is exactly the same. Finally, in this analysis.csv file, it's going to flag files that were made excessively long ago. And so, for example, if you submit an assignment this semester and student turns in something from a previous semester, then likely it'll be less than 2 standard deviations from the average of the creation date. So this was made in 1999, 2000, 2002, and 2001, and might be something we want to look into if this was actually a student's files. So with that information, then we can like look at the files more carefully. We can like export the features using Graderworks. I'll go to my configure and I click on advanced. If I tell it to analyze those questionable files that I want more information about, tell it to analyze and export the feature data, that can give us helpful information about like what's actually going on, who made those features, and who made that actual file. So that's how Graderworks functions, and I hope you found this video demonstration helpful. If you have any questions, let us know on the website. If you have any ideas for how we can make it better, I'd be happy to look into them, and thanks for watching.